It's always so lovely to have you here every Wednesday of the month. Greetings, leaders from the African continent and across the world, and welcome to today's live session. We're going to be talking about soil moisture mapping. My name is Maud Nale. I am the communications lead here at Digital Earth Africa. Soil moisture is a measure of water stored in the soil that is accessible to plant roots, making it a major contributing factor to plant yield and to plant health and crop yield. At this point, I would love to introduce today's presenter, who's going to be talking more on the subject and how the Digital Earth Africa can help you to map soil moisture. She is a lecturer in the Department of Geospatial Information Science based at the African Regional Institute for Geospatial Information Science and Technology, or in short, popularly known as AFRIGIST. They are based in Nigeria. Please join me in welcoming onto the virtual stage Dr. Ozien Phoebe Mamudu, who will be talking about soil moisture mapping. Doctor?
We're going to be talking about soil moisture, and we are going to be talking about it based on the Global Root Zone Moisture Analysis and Forecasting System GRAFS. Now, this is a data set that is available on the DE Africa platform that allows us to be able to analyze soil moisture, root zone moisture, and surface moisture in any given area. Now, just as a quick background, soil moisture is a measure of water stored in the soil zone and is accessible to plants and plant roots. And it gives a major indication of the health of a crop and even the amount of yield that can be expected. Other things that we can use soil moisture analysis for is to analyze the level of dryness in an area, giving us an indication of drought or even desertification. So soil moisture is an important tool to use in analyzing various aspects of our environment, including, of course, plant health, crop yield, desertification, and so on. Now, the data sets we're analyzing is going to be based on the Global Root Zone Moisture Analysis and Forecasting System, which is produced by the ANU Center for Water and Landscape Dynamics. Now, it's based on a surface moisture analysis data set of 0.0 to 5 centimeters ground level and root zone of 0 to 1 meters level for soil moisture, and it's taken at a 10-kilometer spatial resolution globally. Now, it also makes use of the precipitation data measured by the global precipitation measurements, and it uses that to analyze or estimate the soil moisture based on the soil moisture active passive, that's the SMAP mission. Now, let's get right into it. What we are going to be doing today is we're going to retrieve the surface and root zone wetness data set from the GRAFS data set based on the threads. And then we're going to compare that data set to precipitation data from the ERA5. So first of all, we'll go ahead and load our data set, which is already loaded here. We're going to import the X-array, the NumPy, and the data cube. We're also going to load the ERA5 dataset as well as Matplotlib. Sorry. We're going to be able to display maps. We're going to use the plotting tool to display map. We're going to calculate indices, and we're going to load the analysis ready datasets. Next, we connect to the data cube using the codes in this cell here. And following that, we are now going to define our location. Now, the location we are using for this study is the same one we used when we did the desertification notebook 2 weeks ago and even last week, and is the Funugo village in Banikora, part of northern Benin Republic. Now, the coordinates of the area we're using is given here, the latitude as well as the longitude. The time period we're going to be analyzing is a 1-year time window, which is between July 2018 to about May 31st, 2019. So we're going to be looking at the soil moisture over the period of 1 year. And then having defined this, we can now display this in a map. So this is the area of study given by the red bounding box, as we can see here. So we've defined our location and we have imported our data sets. Next is to actually retrieve the surface and root zone wetness for our area of study. And so we are going to load the data sets, the soil moisture data sets, using the codes here. So we are loading it based on the latitude and longitude, which is our location, based on the time, which is 2018 to 2019, and it's based on the product, which is the surface moisture data. We are loading it from the DAPDS nci.org.au datasets, which is where the GRAFS dataset is stored. And then, of course, we have specific parameters. We are retrieving only the surface wetness as well as only the root zone wetness. So other aspects of this is specifying our latitude and longitude range, as well as the product name, which is the GRAFS topsoil relative wetness and the GRAFS root zone soil water index datasets. And so we'll run this code. And after running that, the next we want to do is to retrieve the surface wetness and root zone wetness. So surface wetness retrieval uses this code here, and it's giving us that of 2018 and that of 2019. Similarly, we'll do that of the root zone wetness to load soil moisture, and it gives us that of 2018 and 2019. Now, having retrieved the soil moisture data for both surface moisture and root zone moisture, next we need to do is plot this data. And so in the next step, we are plotting the surface moisture and root zone moisture over our 1 year period to see what the trend in moisture is. And that is given here. Now, if we look at this graph, we can clearly see the periods when we had the highest moisture periods and when we had the lowest moisture and when it eventually started to increase. Now we can clearly see that the period of July to about September, maybe sometime in October, we have the highest amounts of surface and root zone moisture. And then as we move towards November, we can see that it's dropping and it becomes really low through January, through March, and even into April before it starts to go up again in May. So this gives us an indication of what times of the year we have the most amount of moisture in the soil, what times of the year we have the least amount of moisture in the soil. Now, this same data set, we now want to compare with precipitation data. There's basically rainfall data from the ERA5 dataset. And so we will first load the precipitation parameter data from ERA using this code here, loading the variation of precipitation based on the 1 hour accumulation. And we are loading it for our latitude, longitude, and time frame as we specified at the beginning of this notebook. And then after loading it, we now plot the soil moisture and precipitation data sets. So we already have the soil moisture, which is this one given here. And so we'll now plot the precipitation along with the soil moisture data set. And here is what we have. And so we can clearly see that in the periods when we have the most rainfall is when we have the highest surface moisture and root zone moisture, even though we can see some level of fluctuations within, even in the high periods. Now we could see that maybe sometime in about August, thereabout, we have a peak in rainfall, right? And you could also see that even though there was a peak that period, that does not necessarily translate to having the highest peak in soil moisture at that period. However, you can see a range of period where soil moisture is high, corresponding to high rainfall. Now, we also see that from about November, we can see a flatlining of precipitation, indicating that that is mostly a dry season period. However, it doesn't translate to zero soil water index, in that there is still some moisture in the soil, given we still have values, even fluctuating values all through the dry period. It could give us some indications of possibly irrigation going on in that area, or use of manual systems of wetting the soil to ensure that some crop life can still continue. However, we also know that there are certain crops that may thrive more in the rainier season or in the periods when we have high moisture, and there are other crops that might thrive better using drier soils. And so this gives us some indication of the nature of how precipitation affects the moisture in the soil in our study area. So that is it for this notebook. However, if you cast your mind back to what we did in the desertification notebook, we actually also went through soil moisture, but in that case, we looked at a period of time. We looked at 5 years from 2015 to 2020. So you could see what periods of the year soil moisture was high and what periods of the year soil moisture was low, and so on. So we could also explore that. So I want to urge every one of us to explore the soil moisture aspects that are contained in the agriculture and food security training that is available on the e-learning platform, as well as the land degradation training that is also available on the e-learning platform. So thank you, everyone. I'd appreciate questions. Over to you, Maud.
Thank you so much to you, Dr. Phoebe, for that presentation on all things soil moisture. You spoke about a data set to measure soil moisture, Global Root Zone Moisture Analysis and Forecasting System, or GRAFS in short. If you're wanting to access that particular data set, please visit sandbox.digitalearth.africa. I wonder if there are any questions or comments for Dr. Phoebe at this point. Maybe I should change the view of my screen so that I'm able to see everyone. Are there perhaps any questions or comments for Dr. Phoebe at this point? We're a very large group today. Welcome to everyone who I didn't get to pass greetings to earlier when we started. Today we're talking about soil moisture. In case you've just joined us, soil moisture is the measure of water stored in the soil that is accessible to plant roots, making it a major contributing factor to plant health and crop yield. Dr. Phoebe showed us how we can go about doing this using a very specific data set, the GRAFS data set, which is available or accessible via the Digital Earth Africa sandbox. What I also want to do, she did mention it, but I'll mention it again, is if you're wanting to learn more about this, or specifically how to obtain crop productivity using Digital Earth Africa products and services, including the Soil Moisture Notebook, we do have an online course that is already opened. It's called Land Degradation. The website for you to visit to be able to access that course is learn.digitalearthafrica.org, and that particular course is available in English as well as in French. So don't worry, we have you covered. It has been dropped in the chat box and the comment section, learn.digitalearthafrica.org. That course is called Land Degradation. I'm wondering,
give the viewers an overview of the LAN platform with the permission of the moderator.
That is perfect. Our capacity development lead, Dr. Kenneth Mubia, over to you to tell us more about the Digital Earth Africa Learning Platform.
Just in case I have some interruptions, don't worry, I have some young learners with me. Thank you. So the Digital Earth Africa Learning Platform has been developed by co-developed with the partners in this call. And initially we started with the introduction to Sandbox, which is a 6-week training in English and French. And we had the partners from Agrimet Niger, AFRIGIST in Nigeria, OSS in Tunisia, as well as the Regional Center for Mapping, as well as CSE in Senegal. And also after the introduction to Sandbox, we had the water resources, which is very easy in English and French. And then we had agriculture and food security, giving an overview of some of the modules that Dr. Phoebe has talked about, and they have been instrumental in helping us to co-develop the training in English and French. I know also Phoebe speaks some French a little bit and some Pidgin. Okay, so also we have urbanization, which we also co-developed, and I'll be following up with the participants in the course to see where they are stuck. And finally, we have something on land degradation, which was co-developed between the partners AFRIGIST in Nigeria, as well as our partner OSS in Tunisia. And some of the use cases we have on this training are some sites in Benin, as shared by Phoebe. We also have some sites in Burkina Faso and Tunisia. And whatever we have can work across the continent, just to make sure that everyone is connected. And also for those ones who have joined us today for the first time, is that we have this important resource for those who've joined us, especially those ones who've been given the link today. There's a user guide which gives you a step-by-step in case of what has been talked about, like soil moisture. Yeah, you can just come here and get all the literature, because we've had people who want to publish some of the work, or they are looking for the resources, or actually to quote, there's some resource here about the soil moisture, as well as a particular notebook on the same, giving you all the steps which have been described by Phoebe. Also, as you move in this resource, is that you'll see we have the data sources that are available. Also, we have the use of the Digital Earth Africa map, which we'll be able to show you in the next session, just giving you an overview. And also you can access your external web services in case I had some people who wanted to access to data from Planet. You can do it from here, especially the colleagues from World Resource Institute who are working on forestry. Then on the Sandbox, we have all these tools, the datasets, the beginner's guide, and use cases. And all these resources are here for us to use. And finally, the message from one of our partners is that we are working together with Esri to make sure you're able to access the Africa Geoportal, which also Maud has talked about in some of the presentations, that we are working with all partners, and also recently introducing the RCMRD conference, which will be in Nairobi. This will be the first week of August, so that in case you submit a paper, they will be able to sponsor some of your participation, especially those ones coming outside Kenya. So as you can see, the call is still open, that you're able to share some of your abstracts and some of your important work, and be able to connect with our partners soon. And I know AFRIGIST will be having their own workshops so that they can connect with us. Thank you so much, moderator, and over to you. Thank you.
Thank you so much to you, Ken, for showcasing the learning platform here at Digital Earth Africa. I want to encourage the leaders here on the call to go and visit the website learn.digitalearthafrica.org. There might just be a course that would be very helpful with you as you continue with your research, or even if you're just wanting to expand your body of knowledge in that particular field. Dr. Phoebe, I don't know if you can come back onto the virtual mic. There are two questions that have come through. The first one, someone joined late and they just wanted to find out how they can access this data set for processing. That's the data set that you spoke about earlier for the soil moisture. How can one go about doing that?
Okay, like Maud has shared, and even Kenneth has shared, those data sets are available on the Digital Earth Africa platform. And just as I showed in the notebook, all you need to do is to add them, import them, and you can go ahead and run the analysis using the Digital Earth platform, Digital Earth Africa platform. Dr. Ken has also shared something there, so you could also go through that page and see what is contained there. I'm sure you'll be able to see a lot of data sets that you can use. Someone asked something about comparing with thermal bands. We didn't try comparing the soil moisture data with thermal bands, but by all means, feel free to explore doing that and see what kind of results you get. I'm sure we'll be happy to see what results you're able to come up with, what kind of manipulations you're able to do, especially using the sandbox on the Digital Africa platform.
Thank you so much for your feedback on that, Dr. Phoebe, much appreciated. So here at Digital Earth Africa, we're all about connecting people. We work very closely with our partners across the continent to make all of this possible. So if you are keen to submit a paper at the RCMRD conference taking place in early August, the link is in the chat box. It is ric2023.rcmrd.org. And Dr. Ken has also shared the data set. If you perhaps joined us late and were not able to get it, it's GitHub/Digital Earth Africa. And then you follow the rest of the path and you'll be able to get to the data set on the soil moisture. Wednesday in English and in French. So if you loved this session, I'm sure we're going to have it next week in French. I'm not sure, but please do look out on our communication platforms. We will profile all of those topics. If you prefer a live session in French, don't worry, next week, mercredi prochain, next week, Wednesday, that session is going to be in French. We also look forward to connecting with our Francophone community from across the continent. Until we meet again, please take care and be safe. And have yourself a very good morning, good afternoon, a good evening, and a good night. Take care.